All right, let's get started. To my Twitch viewers, thanks for hanging out with me this Monday evening. I really appreciate it. To our YouTube viewers, thanks for checking out another video on the platform. We really appreciate you sticking with the series. 71 videos and still going. Still quite a bit to do. Want to kind of get this test fixture going. Make some more plans to move forward. And maybe start hammering out the details of getting version 2 of the board. The PCBs at least spun up and going. But right now I want to get this test fixture going, finalize some of this, the example coding, and get everything, tidied up so we can start rolling it. So, without further ado, let's go back to VS Code. I found a mistake I had to fix. So we had to, on init, reset the prior cycles as well to equal the cycle count. That way, the logic down here worked properly. But that solved it. So now when the system resets, it'll read the cycle count information from the non-volatile storage and set it, and it basically start like it was never shut down. So the one thing that we need to do is clean up a lot of these, get rid of the RS-45 stuff out of here. We want to be able to incorporate this header basically into the RS-45 system and access this stuff and run commands on it. So what we're going to do is this. We know it works. Let's just start cleaning up all this stuff. Get the RS-45 out of here. It was just in here for troubleshooting, trying to solve our problem. And now that we know what the problem was, all right. No, that's fine. Okay, we can get rid of the RS-45. Clean that up. Oh, we don't need this anymore for now. Let's build it. Make sure all that junk is pulled out of there, because it'll give an error if there's no RS-45. If there's a command in here and there's no header. So I just want to make sure it builds. All right, so it builds. Perfect. So now what we're going to want to do is kind of figure out. So we want to expose some of these variables to the RS-45 interface and eventually the standard FTDI interface for further debugging. Because for right now, they're just going to kind of mirror each other for the system, because we're not writing anything custom for the 485, like Modbus or something. It's just going to basically be a UART connection. So we're going to want to basically expose some of these things to the RS-45 so we can run commands over there. Like get the cycle count. We're going to want to have a command to be able to reset the cycle count. So if, like say we put a new belt on, or we do something different, try a different, we'll want to be able to reset the counter to 0 to start over with our progress. Even with this, to kind of start over from 0 when we're actually ready to run it, get past all the code, get past all the development, and actually run it through its paces. We'll want to do that. Plus, we'll also want to use a non-volatile storage to store the error log. Basically, the error flags. That way, if there's an error, the system can push them down, because this will also be exposed to not only the RS-45, but it'll be the system status, which will probably also, so there's going to be a lot of weird cross exposure, but that's what I want, what we need. So the status system will have exposure to the RS-45 and the NVS system to basically write the error flag. And then the RS-45 will be able to query the status system on things that have happened, but that'll come down the line. So we want to be able to clean this up and make it so that we can easily incorporate all that. So one of the things I was thinking about was an easy way of doing it to make it a little bit more modular, drop in and pluggable. And one of those things is to kind of stick to a basically a memory type, basically a value type, like integer, like 32-bit integer. That way we could rewrite these functions and pass arguments to them. So that's what I was thinking about doing. So yeah, we got to kind of figure this out how we want to do it. So I was thinking the error flag should be a 32-bit integer, and it'll just give us 32 bits to use as different error flags, which would give us plenty of wiggle room to add different errors. So, bit position 1 would be, it's just a generic, was there an error thrown up? It wouldn't be like definitive. It would just tell you basically like bit position 1. If it's high, it would say, hey, we had an error with the limit switches. Bit position 2 would be basically like the NVS system errors. Basically it couldn't open the storage. So anytime we see where we can like throw an error flag, if something doesn't happen right, we can throw it in the status in the flags and kind of get an idea of where it's going. So I think that's what we'll do. We'll just keep it set for integer 32 because that would simplify this. And if we wanted to add additional things to use 32 bits to store, like even just a simple piece of byte data or a couple of bytes into it, we could if we really wanted to, like another memory type, another thing that we want to store in NVS. So that's what we'll do. So I was thinking of making this a little bit more robust. Let's get rid of the status. We'll deal with that later. Only because... So I was thinking of how we can do this because we want to be able to... Because down here... So that opens that. So we need to be able to tell it, first of all, the key and then the value. So we need to be able to send the key and the value pair. So we can send it characters. What I was thinking we might be able to do is... is maybe using an enum. Maybe an enum slash array pair. So it's not going to be clean because other than that, we're going to have to make definitive. I had to kind of break this out, like basically read just for cycles, read just for uh, error flags, and then if we want to expand to other things. And I kind of don't want to do that. I'd like to make it more modular. So let's see if we can play with enums and like an array of the strings for what they mean. So enum. Once my keyboard decides to catch up. So we have the enum. Cycles. Okay. Okay. Let's see if we can figure this out. NVS keys. Okay. So that one would be cycles. This one would be errors. All right. I'm the error. All right. All right. All right. Two. So Mm. Oh, let's see if it gets mad. All right. So those don't return anything, but we want them to be exposed to the system. They're not going to return anything. And we have to go and well, you know. All right. Key. This probably won't work. It's probably going to fail miserably. Key. Cycles. Okay. Well, let's see what that does. I want to see if it explodes on us. Because then, if this doesn't air out, because then we can just pass NVS read and write. Uh, might need to be over here too. Email may have to be over here too. Well, we'll find out. All right, it's gonna puke. Okay. Hmm. Oh, wonder. Yes, what? Okay. Hmm. Not like that's going to do anything. Of course, it's not going to do anything. It's probably going to break, fail miserably. All right. Okay, so it requires constant charge. All right. Wait a minute. It's just an error. Maybe it'll. Okay, 49. MVS read. Okay. May not be able to do it like that. I mean, it's stop complaining. Nope. All right. Yeah, it may not work like that. I may have to figure out a workaround. System.c. Oh, multiple different NDS keys. System.h. Yeah. I think that's going to work. Yeah, I don't think that's going to work. All right. New system at H42. That doesn't really. Unless. Wait, what? Okay. Okay. All right. Okay, so we should be able to have NVS read. To avoid. Dang it. It will return something. Let's see here. Oh, no, no, no. It'll tell it to read it. Don't need to do that. So we're going to need to get cycles. Which is in here. So we're going to need to. Okay. All right, all right. I think this might work. Dude. /. All right. So let's just NVS commands. Status commands. This will get current cycle count. So we don't need to get that. We just okay. Well, let's just get command equals get count. RS45. Okay. So we want it to send. So we want it to basically, yeah, well. Current cycle count is you. It should get the cycle count. Excuse me. Let's see if it builds. So at worst, the cycle count will go up. It just won't write it to the memory. At best, it'll go up and it'll write every 10 increments to the memory. And all right, so we're going to flash this guy. Over here, we'll reset. All right, so I still have some things. Okay, I still have some things doing that. Probably okay. All right, we'll still clean that up. I didn't realize there were still some things printing that. Nope. All right, that's good. Current cycle count is 0. Okay, so that means it hasn't read the memory. Okay. But let's make sure that motor speed. Okay, it's still cycle counting for us. All right. Okay, so it's not reading from the memory, which is something I was afraid of. So the enum's broken, which is perfectly fine. We'll go through and figure out maybe how we're going to have to do that. Let's see here. When it hits 10, does it do anything different? Okay. That actually forced the system to reset. So yeah, our enum system is broken. Okay. So let's put this all back in order. I don't think this will work the way we want it to. All right, let's get rid of this. All right, cycle count. So all this back to default. Now I think we have some of the stuff here in. Okay, top direction. Yep, that's where it's doing the cycle count. This. That. Okay. Don't really need that in a task, but let's get rid of. Get rid of that task. We don't need it. No. All right, we don't need that in a task. Does it build? If it doesn't, what do I need to fix? What did I break? Oh, Media System C. I still have it broken in here. 59. Flash. Now hopefully this is all nice and clean. Doesn't need all the extra garbage. Okay, good. We're back. now. 40. Okay, perfect. So the NVS system still seems to be reading. Okay, let's enable. It's no longer okay, so we could get the current cycle count off of that. We'll make sure it okay, 58. Let's disenable. We will reset the unit. 50. Okay. All right. Okay. So that's working. Okay, so we can get the count over the RS-45 interface. It's not working the way I want to do. Now, what we could do, much as I'd hate to, I hate doing all this duplication, but at the same time, okay. I hate doing all this duplication of code, but I can't think of any way to work because these guys, this requires a constant character. For the okay. So what we could do yeah, this one's going to take some thought process. Because then we also need to have other subcommands to be able to reset without duplicating all this. Wait a minute. The answer might be over here. So it might be down in here. Well, we have to use this. No. No. No, 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 no. Yeah, it doesn't have to be yeah, it doesn't have to be a constant integer. Or yeah, it doesn't have to be a constant string. That's gonna take some thought. Because if we could basically use the S print, I want to make a ceiling wedge. See if there's a way to do it. And to the internet I go. Let's see here. I mean, apparently it's possible to be done. Yeah, no. Might not be able to do this. So I think we're just gonna have to kind of make this a little bit messy to be able to do that. Because we can always use the switch and have different cases for because we do both of them have it read and write, but we don't want to reset the flags. I mean, I guess we could have, one command write everything and read everything and reset everything, I guess. That's something we have to ponder how to do. Maybe we don't need to store the error flags because, I mean, when you power cycle the board, do you really need to have them? Because if there's an error, here, so maybe we don't need it. Let's assume we don't, and let's just kind of keep working under the assumption that we don't need to work on that. Just for now. So we're going to do, so we want to, we need to open the storage. All right, cycles, and we want to set it to 0. 0. Whoops, I don't know why I did that. We need to put that into need to go ahead. This will reset. Don't really need that. Come on, make this shrink. Then we want to call NVS clear out of there. Now we want to build it. Okay, so let's push this over. Okay, we're going to reset. Okay. Okay. Oh. Oh. And I bet you we need to run the read. Though we could set a default cycle count back to 0, but we want to use the NVS data to do that. So. All right, I'll flash you over. Okay. Okay. Oh. Okay, so now we got to go through and all right. 13, stable, reset. 10, okay. We're going to clear count. Okay. Eh. Okay. 17. We're going to reset it, so it's going to probably be 10. Oh. Wait a minute. Why didn't you store? Let's see, maybe it's just 100 milliseconds is too long. Maybe. And when we're talking about a system that works, operates in the microseconds. 50 100 milliseconds is an eternity. It didn't save it. Okay. All right. All right. 53. All right. We're going to disable. So we're going to reset the power. Okay, 50. Okay. Now we're going to give it one last command. No. Actually, we don't need to do anything here because it's going to all be done here. So I like doing one of those little numbers at the end of each of these sections. So let's grab this. All right. This will rest. Reset. Oh, right. Current. Right count. Writing. Clean this up. Yes, right. I don't think we need to do a read because we're just storing that. All right. This way we have the option of rather than current count, and it should work because logically plus 10, will work. I'm hoping. If it doesn't, it doesn't. This will at least give us the option to manually write it before powering the device down. I mean, no big deal otherwise. Okay. Okay. Okay, so it should be like 51. All right. So if logic is right, so if we do it and we get it to at least 61, it should write it. All right. So we're at least at 61. We're going to disable. We're going to reset the device. 61. All right, so it'll work. The logic is functioning. So every 10 cycle counts, it'll still write by default. But because of the way the logic is written, it will continuously increment and count properly and write properly, no matter what cycle count we set, where it's at when we manually tell it to write. Now, we could theoretically at this point have it monitor the GPIO, the boot button, and use that to manually do a write. Because if we're at the device, we can push that real quick, push the boot button. It would write to the NVS, and then we can just turn the device off. So we could, maybe we'll do something like that later. We'll think about it. It's not like it's super super necessity. Being an error factor of 10 cycles is not that big of a deal for what we're trying to do. This isn't, 10 cycles of this TPU belt operating is not like a huge miss. It's not a huge problem. That's an acceptable error margin. So I'm happy with that. So we've got that. We can get the data over RS-45. And I was thinking about putting a sub function in to monitor the account over RS-45, which would be a little bit crazy. So basically, we can put a function monitor count or count monitor, and there'd be a little subtask. Like basically in here, we might have to set a flag, like a bool, like expose a bool, like monitoring count or something. We'll have to figure out, maybe pull in the RS-45 header into here. Oh wow! Just so we can send it. I don't want to do that. But we'll think on that a little bit more. Because then in here it could. I mean. Well, no, if the handle's here. We'll figure that out. Maybe we won't. Hate to have to keep dumping, header files into everything. I'd rather just basically just one way. But we'll see. I'm not terribly worried about that right this minute. Actually, we have RS-45 in here. We can set the bool and pull it in here. And basically here, since we're doing the cycle count, we can put another function or another, if, basically if the bool is, then we just send the cycle count over RS-45. Maybe we can do that. We'll think about that. That way we can monitor it. We'll see how we want to go about it. I don't know. It's not like super important. I'm not like terribly worried. It's not like it takes much effort to, go in a putty and type get count. So it's not that big of a deal. So I think we're in a good spot. The next thing I want to get built up is the air flagging. Again, I thought about writing that to memory, but it's not like super important, because if you power cycle the board, if it's got a limit switch error, it'll show back up no matter what. If there's a thermal issue with the stepper driver, it'll show up no matter what. So I think that's what we'll do, is we'll just kind of like leave it well enough alone for now. And if we see a need for it, then maybe we'll wrap that in. But at least we've got the core started to where we can pull up and get the cycle count, so we can shut the device off. Because I technically don't want to leave it unmonitored for one thing, my cats, and just I don't want any hazards right now. I don't need any problems. I'll only run it while I'm down here in the workshop doing other things, or if I'm in my office, doing other things, whatever, I'll just let it run and I can just monitor it. And kind of get the cycle count over RS-45, because I get the cable run. I've got the 3-conductor cable, a good length of it run between the workshop and my office, so that I can tie into the RS-45 interface and monitor it from my computer. And that would also test the RS-45 and a whole bunch of other stuff. Happiness and a lot of joy off of this. So I thank you for hanging out with me this evening. I know these videos are chaotic and they're not scripted, because I'm completely not 100% sure the direction I want to take the firmware. I want to have enough here for the example code that anybody can open it up, rip it apart, and kind of understand the basic logic of how the system works. But you'll have the complete freedom to learn from these examples and modify them, or just code all new stuff for yourself for this device. It's kind of like how ESP32 dev kits, or this kit, that kit, ships with some basic firmware that does some things, but it's not like everything you can absolutely do with it. It just kind of shows you the possibilities. So that's kind of my goal with this. There's enough firmware here to show you what you can do, how to use the non-volatile memory system, the RS-45. We still have to plug in the temperature sensor, get the files working for that, so we can monitor that and control the fan. We know we can already control the fan, but we want to be able to incorporate the fan into the temperature sensor and the status, and monitor the temperature. We have a whole bunch of stuff to plug and chug and work from there. So again, thanks for hanging out, and we'll see if we can get back to it Wednesday and get some of the error system, the monitoring system, the system status counted out and worked on, so we can start monitoring these flags and testing for some of that. And then hopefully we can start working on the temperature sensor and all the other stuff, and finally get all the firmware wrapped up for this guy. And get it to a point to where we can do some more just benchtop testing while we work on revision 2. So thanks for checking us out, hanging out with us. Have a good rest of your evening, and we'll see you hopefully Wednesday, as long as things go right.